Hi everyone. So in this video, we're going to work through a Year 12 question from the AS sample paper on binomial distribution and hypothesis testing. So for part A of the question, we have the discrete random variable x, and x is binomially distributed with 40 trials and a success rate of 0.27. Find the probability that x is greater than or equal to 16. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Now, if you are happy with your binomial probabilities, you should know that we need to use the binomial CD function for this question. And why is that? Well, when you have inequalities within probabilities, like with this question here, you are accumulating probabilities, okay? So the probability that x is greater than or equal to 16 is the probability that x equals 16 and equals 17 and equals 18 and 19, so on and so on up to 40. You're accumulating probabilities, and the CD stands for cumulative distribution. Cumulative accumulating, okay? So we're going to use CD. So the probability that x is greater than or equal to 16, you can say that this is 1 minus the probability that x is less than or equal to 15, because remember, obviously, binomial is a discrete random variable. Binomial variables take discrete values, whole number values. So this is going to be 1 minus, and then we'll use, again, binomial CD. The maximum number of successes is 15 here. Probability of success is 0. I think it was 27. Yeah, 27. Number of trials was 40. So now we can work this out on the calculator. So 1 minus, and then go into the binomial CD menu of my calculator. X will be 15. Number of trials 40, 0.27 success rate. So this gives me 1 minus 0.949. I'll give a few decimal places here. 0.77, so on and so on. So this is 1 minus the answer. So 1 minus the answer is 0.0509 sig figs. So with these binomial probabilities, you can give your answers to 3 sig figs like so. Perfect. So that's part A done. Now let's go to part B. So past records suggest that 30% of customers who buy baked beans from a large supermarket buy them in single tins. A new manager suspects that there has been a change in the proportion of customers who buy baked beans in single tins. A random sample of 20 customers who had bought baked beans was taken. For part B, write down the hypotheses that should be used to test the manager's suspicion. Now, the manager's suspicion was that there has been a change in the proportion. So when we do this hypothesis test, obviously we have our two hypotheses. Let's write that down here. So you've got your H0, your null hypothesis, and your H1, your alternative hypothesis. So the null hypothesis was the kind of initial status quo belief, or the initial assumption that there were 30% of the customers who bought baked beans in single tins, right? So for H0, we're going to say P is equal to 0.3. That was the initial assumption. Then the manager came along with his new suspicion, and his new suspicion is that that proportion has changed, as we underlined. So this H1 is going to be P not equal to 0.3, and those would be our two hypotheses. So this is going to be basically a two-tailed test. So when you have the not equal to sign in your H naught, you know it's going to be a two-tailed test. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. So for part C, using a 10% level of significance, find the critical region for a two-tailed test to answer the manager's suspicion. You should state the probability of rejection in each tail, which should be less than 0.05. So we're using a 10% level of significance and we want to find the critical region to start with. So remember, the critical region is the set of values that will lead you to reject H naught in a hypothesis test. So we've got this 10% level of significance. Let's just start part C here. So 10% two-tailed test. So that means you need to split the 5% or split 5% into the upper tail and split 5% in the lower tail. Okay, so what we want to do is out of all of the customers, we got 20 customers here in this hypothesis test. So 0, 1, 2, 3, all the way up to 20. We're going to work out the probabilities, or again, cumulative probabilities using inequality symbols of getting a certain number of successes. And we're going to compare it with 5% in each tail. So 5% in the lower tail of numbers versus 5% in the upper tail of numbers. So what we can do, I mean, if we just start by working out the probability, for example, in the lower tail, that X is less than or equal to, let's just start with 1, for example. So again, in this case, I'm just going to make it clear we've got 20 customers and we had a success rate of 0.3, assuming that H naught is true, assuming H naught. So if we do this on the calculator, again, binomial CD, because we're using inequality symbols. So in this case, X would be 1, number of trials 20, 0.3 success rate. So this gives me a probability of 0.0076. That would round to 4. Yeah, 4. So that is obviously less than 5%, the 5% in the lower tail. So 1 is certainly going to be in the critical region, and so is 0. 0 will certainly be in the critical region too. So now probability that X is less than or equal to 2. Let's go up to 2. So this time if X was 2 instead, the biggest value was 2. This gives us 0.035, and then that would round to 5 to 3 sig figs. So that's still less than 5%. So I would imagine if we go up to 3, we try 3 now instead. This gives us 0.107. Okay, now that's bigger than 5%. So therefore, the critical region, or the lower tail of the critical region, I'll say the lower tail of critical region is going to be 0, 1, and 2. So 0, 1, 2. Perfect. Now let's focus on the upper tail. So again, if we think about our distribution here, we've got 20 customers, 0.3 success rate. You would expect 6 customers, so 0.3 times 20, 6 customers to buy the single tins of baked beans. Okay, that's what you'd expect. So let's just trial out the probability that X is, let's go with greater than 10, or greater than or equal to 10 in the upper tail. Let's start with that one. So of course, this is 1 minus the probability that X is less than or equal to 9. So again, using binomial CD for 9, if we put in X is 9, and then 20 trials, 0.3 success rate. So this gives us 0.952. And then if we do 1 minus the answer, this gives us 0.04796. So that's less than 5%, just less than 5%. So that means if we go down to 9, so X is greater than or equal to 9, this is going to be 1 minus the probability that X is less than or equal to 8. Should hopefully give us a number bigger than 5% this time. So again, we'll go back to binomial CD. X is 8. So this is 0.886666853. If we do 1 minus that number, 1 minus that number, this gives us 0.113, which is obviously bigger than 5%. So 9 is not in the critical region, but 10 is. Okay, so for the upper tail for critical region is going to be from 10 to 30. Well, sorry, not 30, 20, 20 customers. So 10, 11, 12, up to 20. So if we just go back to the question was asking for the critical region, and we should state the probability of rejection in each tail. Okay, so the critical region, our final answer for the critical region is going to be the set of X values such that X is less than or equal to 2, because that was the lower tail there. Union with the set of X values such that X is greater than or equal to 10. Now, to be honest with this question, what I really should have done, I really should have defined what X is. So what I'm just going to do here, I'm just going to say that let X be binomial with 20 trials and 0.3 success rate. Because the thing is, if we go back to part A, they've already used a capital X in part A. So I just want to make it really clear to the examiner what this brand new X is. Maybe you could put like a little subscript by the X just to differentiate it from the part AX, but I don't think it will matter too much. As long as you make it clear what this X is and then it's a different X in part A, then hopefully that should all be fine. So that's critical region, and the probability of rejection here. So prob of rejection for the lower tail. So that was equal to this probability here, 0.0355. So 0.0355. And the probability of rejection for the upper tail was this number there. So this probability of rejection is 0.04796. Perfect. So that's part C done. Great. So now let's go to part D. So find the actual significance level of a test based on your critical region for part C. Okay, so the actual significance level, hopefully you know this definition. The actual significance level is the probability of rejecting H0 given H0 is true. So in other words, it's basically the probability of rejection, the two probabilities of rejection added together. That's what it is. So this answer is going to be the two numbers we just worked out, summed up basically. So actual sig level is 0.0355 plus 0.04796. So this gives us 0.0355 plus 0.04796, 0.08, and then 346. So that should be a 6 there. So this is about 8.35% to 3 sig figs. That's our sig level there, our actual sig level. Perfect. So that's part D done. Now let's go to part E. So one afternoon, the manager observes that 12 of the 20 customers who bought baked beans bought their tins or bought their beans in single tins. Comment on the manager's suspicion in the light of this observation. Right, so 12 was the observation. If we go to our critical region from part C, you will see that 12 is in the critical region. So what we can say for part E, and I'm going to try and do this down here because I'm running out of room. We can say that 12 is in critical region. So if an observation is in the critical region, that means you reject H naught. So reject H naught, and you can say that there is sufficient evidence to support the manager's claim, because the manager claimed the proportion was different from 30%. H naught said that the proportion was 30%. So with rejecting H naught, there is sufficient evidence to support manager's claim. His claim that proportion is different from 30%. Proportion is different to 30%. Perfect. So that's part E. Now, there's one more part to this question, part F. So later it was discovered that the local scout group visited the supermarket that afternoon to buy food for their camping trip. Okay, so this afternoon where there were 20 customers, it seems that these 20 customers were from a local scout group. Comment on the validity of the model used to obtain the answer. To obtain the answer to part E, giving a reason for your answer. So we're commenting, or we need to comment on the validity of the model. Okay, so what was the model? The model was a binomial model. Okay, so the model was binomial where X is a binomial distribution, 20 trials, and a 0.3 success rate. So remember, for a binomial to be true, you need obviously two outcomes. You either buy the single tins or you don't. So two outcomes, that's fine. You need a fixed number of customers, 20 people in the scout group. So, seems like we've got a fixed number of trials, fixed number of people. That seems fine. And we need a fixed probability of success, 0.3. And we need to make sure that the trials are independent. So that means that when or if one person from the group buys a single tin, does that affect the chance of the others buying single tins? So you could make the argument here that if one member of the scout group bought a single tin, then that could impact the chance of the others, because if one person buys the single tin, then maybe the others do or don't. Or maybe if it's a scout group, maybe they don't buy the single tins and they all buy other groups of tins rather than just single tins. So I'm going to use that argument for this question here. And I'm going to write this, I think, down here in this part of the question. So, what we can say here is that we need trials to be independent, for the model binomial 20 trials, 0.3 success rate to hold. But if one member of the scout group does or doesn't buy singletons, this is likely to impact whether the others in the group buy singletons, which would invalidate, let's write this a bit neater, sorry, which would invalidate the model assumption necessary. Perfect. So hopefully that makes sense for that answer there. If you do have any questions, do feel free to drop a comment below. Otherwise, I'll catch you in the next video.